Hello everyone, November 29th. We have another difficult question. Let's take a look. Minimum 1-bit operations to make integer 0. Alright, let's do this. Given an integer n, you must transform it into 0 using the following operations any number of times. Change the rightmost bit in the binary representation of n. Change the ith bit in the binary representation of n if the I minus 1, where I minus 1 is to the right bit, is set to 1, and the I minus 2 bit and I minus 2 through 0 bits are set to 0. You can use the following operation, so we can change the rightmost bit, okay? And we change the ith bit if the I minus 1 bit is set to 1 and the I minus 2 bit through 0th bit are set to 0. Okay, I think I understand what it's trying to say. So 3 is 1, 1, so I can change this, so I change the 0. But we cannot change this, right? Because if I want to change the ith bit, the 1 bit, then the I minus 1 bit must be set. So in this case, I'm stuck. You're telling me 2 is stuck. Change the second operation. The 0th bit is 1. Yes. And then change. Oh, that's interesting. Doesn't matter. I just want to see what's 2. 1, 0. Expected 3. Oh, you need to change this into 1. And then change. Oh my god. Oh, okay. All right, let's have another example. 6. 1, 1, 0, right? So I can change this because this is 1, so I can change a 0, 1, 0. Now it's a 2, right? So I need to change this one to 1 and then change this to 0 and then change this to 0. So I need 4 steps. 1, right? 1, 2. Oh, I skipped a 1. I put those two together. So it'll be 0, 1, 0, 0, 1, 1. And then so we're 1, 2, 3, 4. 4 steps. It's interesting. We kind of, I think I kind of, so 1 is 1. Just change this. 2 needs 3 steps, right? 1. So 1, 0 needs 3 steps. 3 needs 2, right? Because I change this, I change this. A 0 needs 0, right? 4 is 1, 0, 0. Ooh, interesting. 1, 0, 0. I can always change this, but in this case, change this doesn't mean anything because I have a 1 followed by 0. So we'll change the ith bit, right? If the I minus 1 bit is set, but this one is not set. Dude, I have to go. There's nothing I can change. So the only thing I can change is the last one. So what? 1, 0, 1. And I can change the ith bit in the binary representation if the I minus 1 bit is set. Yeah, because in this case, 1, 1, right? I can change the first one to 0. The 0th bit is 1, so this is 1, so I can change this into 1. Yeah, because this has to be 1 for this to change. I change it to 1. And then I can change this. No, I can change to this. Now it's 110. As 110, we know this is 4 steps. So this requires 4 steps. So total is 6 steps. 4 is 6. You're kidding me. Oh, my bad. I forgot this step. 110. Yeah, it's 7 steps. Okay. So if I get a binary representation, hold on, I still, how about 5? 4 is 7, right? 5 is 101. 101 we encountered. So 101 has to go to 111, then do 110, yeah, then do 110, then have a shift 4. So this is 6. So 5 is 6. 5 is 6. And 6 we know is 4. 7, we have this already. 7. 7 is 1. 7 is 5, right? 8. Okay, it's starting to find a thing. So 8 will be like this, right? So to find 8, we have to change. So we need to turn 8 into 1111, right? That's the goal. Because when we turn into that, we can hold a second. To change this, we need this to be 1. No, we have to turn, so to make that, we have to turn it into this. Right? Just like to change this, we have to turn into 110. Right? 110. So turn this, we have to turn into 1100. Which means we need to turn 000 into 100. How we do that? Well, if you are 000, the only thing you can change is the last one, right? So you go 1001, right? You go 1001. And when you go that, because 01 can change, right? Yeah, so you can go into 10, right? You can go to 10. And hold on. Yeah, the goal is 1100. Okay, so we have the goal. So this will change it to 1001 for sure. We just want to make this to be a 1, right? To have this be a 101. And we can change this because this is a 1. So I can change this into 1, 1, right? But I cannot change this because this is a 1. So I have to change into a 0. This I can do. Then I can change this, right? Because this is a 1, everything is 0. And then I can not change this. Like I want this to become 0, but I cannot change this. But what I can do is change this into this. Right? Once I change into this, Then I can change this into a 0. Then I can change this into a 0. Boom, I got this, right? Then I can shred the 1 to become 1, 0, 0. Now it's a 4. Now it's plus 7. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 15. 15. So that's 8. Is it 15? It is 15. Right? And then, yeah, we can actually go 8, 9, 10, 11, 12, 13, 14, 15. Right? So 8 is 15, right? So we say 8 is 15. 9 is this, right? So 9 is 14. 10. 9 is this. 10 is this, right? So we skip 1. So that's 13 is 12. 11. 11 is this. 11 is 11. 12. 12 is this plus 1. So 1, 1, 0, 0. That's 12. 7, 8. 12 is 8. 13 is 9. 14. 11. 15 is 10. 15 is here. 1, 2, 3. Fifteen, 14, 12. Ugh, 11, 13. 8, 9, 11, 10. Yep. So 11 appears twice, so this is wrong. Which one is 11? This is 11, right? No, hold on. 11 is this. 8 plus 2. Yeah, this is 11. So it's 1, 2, 3, 4, 5, 6. Yeah, 11, 13. How are you going to... Oh, man. I don't know. How do we figure? So you're given a value, right? You're given a value. You can't just go from the start. I mean, it has to analyze how this one goes. I think, yeah, so the one observation is when you're doing this, you're moving things around, right? And you're going down back to 0. You will go through every single combinations, which means if you start from 2 to the n minus 1, your steps, you start from 2 to the n, then your steps must be 2 to the n plus 1 minus 1. So this is 2 to the 3, so it'll be 2 to the 4 minus 1, right? That is clear, because from this to go back down, every time you change 1, and you don't want to duplicate the changes, so you want each state, right? You want each change to be unique. So to go from the top all the way back down, you have to go through every single one once, right? So that's that. So now the difficult part is every other value along the way. How do you figure, right? How do you figure to go from there back down, right? how do you figure? And it's not really that straightforward, if you know what I mean. So there's always going to be a point where we fill out everything, right? There'll be a point where we fill out everything, and then after that, can we figure out how I need all that. Let me do it one more time. So we know 1 1 1 1. Yeah, I probably need this 1 1 1 1 1 1 0 1, right? Just kind of the change 1 1 0 1, and then because we want to remove this, right? Oh yeah, and then 1 1 0 0, and then 0 1 0 0. You go to the lower, right? You go to the lower. So this we don't have to continue. So we know this is 2 to the third minus 1. This is 7. We know. Okay. So if I have more, let's say 1 1 1 1 1, right? So of course the only one I can change is this, right? And then I can change this. The goal is to make it into 1 0 0 1 0 0 0, right? So we need to make it into 1 1. So this one has to be 1. So no, this one has to be 0. How do we make this one into 0? Do we go back down? Yeah, we have to, because this one go back down. Because if you are here, the only change you can make is this one into 0. You can't make any other changes. Oh, you can change this to 0, but I don't see if you change this into a 0, then you can make this into a 0. Yeah, I don't think so. So we make this into 0, now we have a 1 1 1 0 0. Then we have this kind of 1 1 0 1 1 1 0 0. And then what? Then you can change this into a 0. 1 0 1 0 0. Then how do you make this? We need to make this into a 0. So 1 0. So how do you make? Hold a second. Hold a second. You don't need all that. You don't need all that. This, I want to turn this into what? I want to turn this into 1 1 0 0 0, because that's how I can remove this. So this is equivalent to turn. So it's equivalent to turn 1 1 1 1 into 1 0 0 0. How do we do that? Well, it's the freaking reverse. Right? We just do the reverse. We'll take 1 2 3 4 5 steps. Okay, so it take 5 steps. So it take 5 steps, right? And then we turn it into this, and then this is another 15 steps. So it'll be 5 steps plus 1 step plus 15 steps. So that will be 21 steps. What's this? It's 31, right? Yeah, 31. This is 2 to the 0 1 2 3 4. Yeah, 16 plus 8 plus 4 plus 2 plus 1. So that, I say, is 21. It is 21. So we kind of, get the kind of flow, but it's not enough, right? It's like we need to know the previous. Then we know, yeah, exactly. So you're giving me any value, like say 1, 0, 1, 0, 1. They give me this, right? So I know I need to convert this into 1, 1, 0, 0, 0. Therefore, I need to know how to go from 0, 1, 0, 1 to 1, 0, 0, 0, or the other way around. Doesn't really matter. So basically from here they go into here, right? How are we gonna do that? Because the only way is, you have to do this, but it's, what in the hell? Does it go both ways? Yeah, because I know from 1, 0, 0, 0 to 1, 0, 0 is, I know how many steps. Huh. How many steps? 1, 0, 0 to 1, 0, 0. From this to this, I have to go through every single combination, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. 8. You have to go through every combination. So we can go here. So it's 8 steps, right? So we have to go through 8 steps, right? So this is 8 steps, and plus 1, let's say 9 steps. Okay, so this would take 9 steps, right? And then down to this would take 1 step, and then this to would be 15 steps. So 25. What's 1, 0, 1, 0, 1? 1, 0, 1, 0, 1. It's 16 plus 4 is 21. It's 21. Give me 25. It is 25. How'd you summarize this whole thing? How many different... it's hard to say. Like, you say from... Well, it doesn't really matter, does it? Yeah, it doesn't really matter because we want, given any value, we start from 1 and then end with something. And let me just try one more, just kind of gauge it. So let's say 1, 1, 0, 1, 1, like this one, right? So basically, when you give a value, we take the first out, right? We don't know what this is, so we have the remainder, right? So we want to go the remainder to make it turn into 1 followed by zeros. Okay, so now the question is how many steps it takes from this to this, right? Which is equivalent to, say, we can take this out. So how many is from 0, 1, 1 to 0, 0, 0, right? Which is equivalent how to get this to this. Well, to get this to this, we need, so to get 11 to 0, we need change the first one, but this is already 1, right? So maybe that's when we stop, right? So 11 to 0. Right, it's gonna be whatever it is, we want to go to 0. So we take out the first, will be something to 0, right? So basically from anything to 0, it's the same. It will be from this to 1000, how many? Yeah, so no matter what you give me, right? Hold on, let me do it one more time. No matter what you give me, the first task is I'll isolate this. So I say I want to turn this into 1 0 0 0 0 0 0 0 0 0, right? What term? Oh, that's what's this thing? Lord, I have to translate this. 1 0 1 1 0 1 0 0 1 0 1. Right, 1445. Okay, 1445. Yeah. So first we need to do is convert this to this, right? So now the problem transformed into, and when the concepts will be, we'll do one step, right? We'll do this, so it will be the dp 0 1 1 0 1 0 0 1 0, right? Dp this, because this convert to 0, right? It would be dp this plus 1, because I converted this, so it'll be 1 1, so plus 1, and then plus how many this is. So how many is this? 1 2 3 4 5 6 7 8 9 10, right? So it'd be 2 to the 11 minus 1. Right, 2 to the 11 minus 1. So now we're going to do this. So this is 1 1 0 1 0 0 1 0. So we turn this into 1 0 0 0 0 0 0 0, right? So this will be dp 1 0 1 0 0 1 0 plus 1 plus 2 to the 1 2 3 4 5 6. Wait, hold a second. I think I got it wrong. This is 15, which is 1 2 3 4. Yep, this would be to the 10th. Because of 1 2 3 4 5 6 7 8 9 10. This is a 1. 1 2 3 4 5 6 7. Right, so 2 to the 7 minus 1. So we have 10 digits and we lose 1, right? 1 1 0 1 0 0 1 0 1 2 3 4 5 6 7. Wait, hold on. Yeah, 1 2 3. No, 1 2 3 4 5 6 7 8 is 8. It's 8. Because you convert this into 0, right? You convert this into 0, and they have an extra 1. So that you convert, and then you convert this thing to 0, right? Which is this. Now next we'll do this. So we'll be convert 1 0 1 0 0 1 0 into 1 0 0 0 0 0 0, which is dp basically 1 0 0 1 0 plus 1 plus 2 to the 1 2 3 4 5 1 2 3 4 5 6 7, right? 7 minus 1, and then we will do again. So it'll be 1 0 0 1 0 turn into 1 0 0 0 0, which will causing you just dp10, not 10, dp1, 0, plus 1 plus 2 to the 1, 2, 3, 4, 5 minus 1. And eventually it's dp1, 0. I think when we get to 1, 0, you can do the same. You can say dp 1, 0 turn into 1, 0. Nah, you don't do. I think when we get to 2, we can just say dp2 is 3. Right? dp2 is 3. So the answer is at the end, and then all of this can cancel. Right? So at the end is 3, which essentially is, now I just say 3 plus 2 to the 5, right? 3 plus 2 to the 5, and then plus 2 to the 7, plus 2 to the 8, plus 2 to the 10. Aha. What is this? 1445. It's a giant value, and I need a. It's actually not a giant value, but we can compute. Let's see what we have. 2 to the 10 plus 2 to the 8 plus 2 to the 7 plus 2 to the 5 plus, is that 3? Yeah, I remember it is 3. I remember, yeah, 2 to the plus 3. Oh, that's not right. Got a different value. I got 1443. Shoot. Let's do this one more time. Let's do this one. I think we are on the right track. It's just, maybe somewhere along the way we didn't do it right. 10, 8, 10, 8, 7, 5, 3. It's not correct. All right, let's do one more time. It's okay. All right, let's do it one more time. Okay, we start from 1, 0, 1. 1, 0, 1, 0, 0, 1, 0, 1. Okay. So the first is to turn 0, 1, 1, and then this 0 we don't. 0, 1, 1, 0, 1, 0, 0, 1, 0, 1. We turn this into 1, 0, 0, 0, 0, 0, 0, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we turn this into this, right? And once we turn this into this, oh yeah, there's something wrong here, because it's not just turning this into 0. We have also a 1 in this front. How are we gonna do that? Exactly, how are we gonna do that? How are we going to do that? Yeah, I think this is the last part. Of course, we are doing this turn into 0. Okay, but how do we add an extra 1 at the front? Like seriously, how do we add extra 1 in the front? We add extra 1. Huh. How? I mean, I can say if we have this situation, we need to go from this. Maybe. I'm just thinking. We need to go from this to 1, 1, right? And then we have 2, 3, 4, 5, 6, 7, 8. We go from this to this, and then we get 1, 2, 3, 4, 5, 6, 7, 8, and then right, and then we go from this so yeah, so we go from this. So hold on. So we go from 1, 1, 0, 1, 0, 0, 1, 0, 1 to 1, 0, 0, 0, 0, 0, 0, 0, 0. Go from this to this, and from this to this. I can do that, right? It's just one step. And from this to 1, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Basically going to change from this all the way to this. And now we can remove the front. So from this to this, this is good. We know how to do this. From this to this, we know how to do this. From this to this is equivalent from this 1, 2, 3, 4, 5, 6, 7, 8 to 0. So we know how to do that as well. Okay. Okay. Almost there. Let's start from 0, right? Start from 0 is a little bit tricky. So start from 0, we do the remainder, right? We do the remainder. Yeah, so this to this we ignore, so we just do this part. So if it's a 1, right, so this is equivalent to so hold on. So if it's 1, 0, something, right? So what we need is to turn this 0, something into 1, 0, 0, 0, 0, right? And to do that, what if we have multiple zeros? So we have multiple zeros. Yeah, hold on. So we can have multiple zeros. Okay, so have basically this is 1, 0, and then 1, something. So this can be k zeros here. K can be 0, right? So to do that, we find the first, that's a 1, right? We find the first, that's a 1, and convert this problem into dp the same, 1, something, right? Because this is how many steps this one will go into 0. Done, because that's what we want. We want this whole thing to become 0. Right? And we want the whole thing, this whole thing to become 0. So now, so we say this whole thing to become 0. And then what we need to do is Hold on. We want this whole thing to become 0. Huh? Isn't we solved this problem already? Right? Yeah, we want this whole thing to become 0. And then it's become a 1, 0, 0 something. We know the answer to that. So we don't even need these convoluted steps. This is it. This is it. This is it. We just find this to become 0, right? And then the original. So in this case, hold on. I think we're almost there. We're almost there. Right? So what we want is to do, so we want to find dp this, right? So this is equal to dp 1101001001 plus because it becomes 0, so that's 1 2 3 4 1 2 3 4 5 6 7 8 9 10 11 2 times 2 to the 11 minus 1. So this will equal to dp. So we'll turn this into 0. So 101001001 plus 2 to the 11th minus 1 plus 1 2 3 4 5 6 7 8 9 minus 1. This will equal to dp 100101 plus 2 to the 11th, 2 to the 9th, and 1 2 3 4 5 6 7 8 2 to the 8th minus 1. So this will equal to dp 101 plus 2 to the 11th, 2 to the 9th, 2 to the 8th, 2 to the 1 2 3 4 5 6 minus 1. And this will equal to dp 1 plus 2 to the 11th, 2 to the 9th, 2 to the 8th, 2 to the 6th, 2 to the 1 to 3 minus 1. And dp1 is 1. So this is equal to 1. And in this case, dp10, yeah, dp10 can compute. dp11, yeah, we can compute. Because dp11, like dp11 shall equal to dp1 plus 2 to the 1, 2 minus 1. That's not right. So if dp1 is 1 plus 2 to the 2 minus 1 is equal to 4. Wait, 3 is 4? Ah, 3 is 2. Because 1 0 is 3. That's not all correct. dp11 doesn't follow this because it's. I think what we need to do is these are special cases. These are special cases because it's you can change it because 1 1 you can change this immediately, but 1 1 0 you can change this as well. 1 1 0 you can always change this, right? But if you change this you cannot change. But if you can change this is the last one you can change. Therefore, 2 digits are special. So we're going to say, dp0 is a 0, dp1 is a 1, dp2, which is 1 0, is a 3, right? That makes sense. And then dp3 is a 2, right? That's just the edge case. Everybody else can follow this. So in this case, let's compute 1 plus 2 to the 11 minus 1 plus 2 to the 9th, minus 1 plus 2 to the 8th, minus 1 plus 2 to the, that's a 6, right? Minus 1 plus 2 to the 3, minus 1. Oh, Lord, it's not right. It's 2,884. That is bonkers. Now it's still far. I mean, 2 to the 11th already too big, right? Yeah, this 2 to the 11th is too big. Nah, it's not this. We cannot go all the way to 1 all the way 0. Because we can simplify it. Yeah, no, this is not right. Nah, this is not right. This ain't right. This is not right. This is not right. What else do you think? We're at a cusp. We're really, really at a cusp. We're almost there. Almost there. Come on. Again, I think it is correct that we want to reduce it. So we want to turn this, right? We want to turn this into 1 1 0 0 0 0 0 0 0 0 0, because when you do that, this one is free. You remove this for free, right? You remove this. So if you turn this into this, you remove this and then you just do this. Done, right? So now the question is, we need to turn 0 1 1 0 1 0 0 1 0 1 into a 1 0 0 0 0 0 0 0 0 0. How do we do that? Now there is a way. I think I figured out a way. So to do that, which means we want to turn this into a 1. How are we going to turn this into a 1? So if you want to turn this into a 1, so this has to be a 1, and everybody else has to be 0, right? So to turn this into this, we need to turn so it has to be, there's an intermediate step, right? So it has to be a 0 1 0 0 0 0 0 0 0 0. So this turn into this, and you can change this. That ain't right. We want to turn into this. Dear Lord. Right, we turn into this, and this can turn into 1 1, because this is a 1, everybody is 0, so we can do this, no problem. Then we will turn this into this, which is essentially turning this into 0. Okay. So again, so we want to turn this into this, right? Which is turning this into this, which is, oh my God, and turning this into this. right? Turning this into this, which is equivalent to turning this into 0. So what if we have multiple zeros? So we want to turn this into 0. So we need to turn this into 1 1 0 0 0 0 0 0, right? So we need to make this happen. And to make this happen, we need to make 0 0 0 1 1 0 1 to turn into 0 1 0 0 0 0 0, because when you do here you can change this, right? When you here you can change this, which is turning this into, yeah, now we're doing the same thing, right? We're doing the same thing. So there are like what, 2 sets of recursion. So to turn this into this is equivalent to turning 0 0 1 1 0 into 0 1 0 0 0, because from here I can turn into this, right? So we are going to turn this. To do this is equivalent to go 0 1 1 0. We need to turn that into a 0 1 0 0, right? Now we're starting from 1. Which means if I turn this into 1 0 0, into 0 1 0 0, I can turn 0 1 0 0 into a 1 1 1 0 0, right? And a 1 1 0 0, I can turn 1 0 0 into a 0. So I get this, right? And when I get this, I can get 1 1 0 0, and I'll turn this into 0. So when we have something start from 0, let's say we have 3 zeros, right? So we get rid of all the zeros. So we know we have 3 zeros. Oh, 0 1. I forgot a 1. And then this will be, dp 1 1 0 1, right? Oh, that's not right, because we are, no, this is dp 1 0 1, because we can skip this first 1. Wait, hold a second. That's so we do dp 1 1 0 1, right? Turn this into 0. Then I'll have yeah, that's the thing, right? That's the thing. You have whatever the original 1 with k zeros, and then you have a 1, and then you have whatever you have, right? So the goal is to turn this remaining into 0, right? Let's turn this remaining into 0. So once you turn this remaining into 0, you have a, just basically like a dp, right? Just recursion. You turn this into 0, you know how many steps. And then you have a 1 here. Then you just need to turn 1, bunch of k, and then 1, bunch of 0. It doesn't matter. P, you have a P0. So you turn this, right? Because we need to remove this, you have to turn this into 1, 1, or 0. And to do that, you can always make this a 1, right? You make this a 1. So you have now k minus 1, that's 0, have a 1, 1, and then everybody's 0. So that will take 1 step, right? That take 1 step, you change this into a 1 because this is a 1, everybody else is 0. So you change that. So you change that to 1. And then we need to turn this into, so we turn this into 0. So that's 2 to the whatever power. And then you plus 1, 2 to the whatever power, plus 1, 2 to the whatever power. Okay. Okay. So can we make some calculations here? Dude, this is gonna take a long time. I mean, to even get this all out. All right, so this is the same, right? So we have 1k, right? So we want is find the next one, turn the remaining into 0, and then depending on how many, because I have a k zeros, right? Yeah, let's say we have p, exactly. Yeah, let's just do this. We have p, okay, and then we will do plus 1. We have, so we have this is p plus 1. And then we have 0, k minus 1, 0. We have a 1, and we have 0. That is p plus 1, 0. So this step will take 2 to the, this is a p plus 1, because I have p0 initially, right? Then we grab 1, so it will be 2 to the p plus 1 minus 1 step. So we get to here. And then I will change again. So this will be k minus 2, 0. 1, 1, all the way 0. Now this have p plus 2. Now we plus 1 again. And we turn this into 1, k minus 2, and 1, all the way 0, p plus 2. Right? So that will be plus 2 to the p plus 2 minus 1. Right? So to turn this into this, because I have a k, right? So that will be 1 plus 2 times 2 to the p plus 1 minus 1. This will turn into this. Will be k minus 1. Right? K minus 1, 1, and then p plus 1. And then we'll get 1 plus 2 to the p plus 2 minus 1. This one will get to k minus 2, p plus 2, right? And then 1 plus 2 to the p plus 3 minus 1 will give me 1, 0. We have k minus 3, 1. And then this is p plus 3, right? So all the way down, eventually we want 0, right? Which is k minus k. So we do 1 plus 2 to the p plus k, right? P plus K. Because to this step, right, minus 1, minus 2, all the way at minus K. So it will be 1, 1, 0. This will be P plus K minus 1, right? So if we add this together, these go. So it'll be 2 to the P plus 1 plus 2 to the P plus 2 plus all the way to 2 to the P plus K. That is the formula to turn this shape into this shape. Right? To turn this shape into this shape. To turn this shape into this shape. And then once we get into this shape, so P is the number of zeros after the 1. Right? Okay. So now we need to compute this thing. So this, we start with, we analyze this, right? So 1 bunch of K. So K is, so in this case, K is equal to 1. P is equal to, so K is equal to 1. We have a 1, so it'll be 1, 2, 3, 4, 5, 6, 7, 8. P is equal to 8. Right? P is equal to 8. Oh, I can write a thing for this. Hold on. I can write a thing for this. So 2 to the P is 2 plus 2 squared plus all the way plus 2 to the K, right? 1 to K. Yeah. So what's this? What's this? It's there's a formula. I forgot. I'm basically doing it by hand. So 2s minus s will equal to 2 to the K plus 1 minus 2. So s will equal to, so 2 to the, let's say r. Right, this is r plus 1 minus 2. So yeah, so it's going to be divided by 2 minus 1. Right, in this case, just 2 to the K minus 1. So it's just equal to 2 to the K plus 1 minus 2. Yep. So we outside has a P. So just 2 to the P, 2 to the K plus 1 minus 2. So that is the formula. Okay. So this will equal to 2 to the P, 2 to the K plus 1 minus 2. Okay. So this is important. So we have K equal to 1, P equal to 8, right? So we'll turn this into this. So dp this shall equal to 2 to the 8th power 2 to the 1 plus 1 minus 2. So that plus dp. So we know that this will be 1, 0, 1, 1, 0, 1, 0, 0, 1, 0, 1. Will be dp this, right? So dp this will turn this into 0. This will turn this whole shenanigans into this. And we'll plus 1, let's remove the first 0, and then plus the whole count. So we can also say the whole count is the C count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? So 11, but we already realized, so it'll be 10, right? So it'll be 2 to the C minus 1 Oh yeah, 11 minus 1, right? 11 minus 1 minus 1. Okay. So now we have to compute this dp. So now we have to do dp. Maybe it'll be easier if we just go, you know, because we already figured it out. Okay, we already figured it out. But I hope it's correct. I'm not Java this thing for sure, because I need to manipulate. Okay, let's Python this. Let's Python this thing. For 30th, right? I thought I copied it. No way. No way. It's inconsistent. Wait, how is this possible? Oh my goodness. This is absolutely bonkers. I use different file system. Oh my god. Oh my dear god. Oh Lord. Yep, it used to be this, but then I changed into, oh my goodness. No, I like this. I want year at the front. I don't know why I used to do the other way. It's absolutely stupid. Okay? It's absolutely stupid. Oh. Alright, let's give this a shot. Alright, it's just a recursion. Right? Recursion. So what we have to do is we need to define a recursion. We call it helper. And what we're gonna put in is str. So it's gonna be an str. We're gonna return an int. Okay, return an int. We need to first find out all the required digit. What if there's no 0? If there's no 0, then k is 0. Then, yeah, if it's a 1, 1 something, then we just turn the remaining into 0, right? We turn the remaining into 0. So it's the same thing. Wait, hold on. Because we find the first one, right? And then we turn the remaining into 0. Yeah, it's the same thing. We turn the remaining into 0. So this will be 0. This is remaining plus 1 plus, yes. It's the same stuff. Okay, so we need to find, actually we don't need this. I just need because strn can start with 0, so we need to get rid of all the zeros and need to find the first one, right? We're gonna find the first one, and we find the first one, then we find, okay, let's just have I equals 0. Okay, we find the first one, so find the first one. Okay, so find the first one. We say while strn I is equal to 0. Okay. I plus equal 1. All right, so now we find the first one, right? So first bit index is equal to I. Okay. Now we need to count the number of zeros, so which is in this case k. So k equal to 0. And while strn I is equal to 0. No, I need to plus equal 1. Hold on. Let's go up. I plus equal 1, right? Now we need to find the number of 0. The number of 0 between the first and second 1 bit. So I plus equal 1. So I say if it's equal to 0, k will be plus equal 1. I will also have to say k is the count. Hold on. Find a number of zeros between and store it and save it in k. Okay. So k plus equal 1, blah blah blah. When we're done, I plus equal 1. Ooh, you might. Dang it. So have to be I need to smaller than str, len str, and this. Yeah. Okay, so I smaller than len str and this. So we have k, right? And then what we need to do is to check the I. Okay, to check the I. If I goes out, right? If I goes out, and so we find the first 0. We'll find the first one. We always find the first one. Okay. What if I can't? The first bit actually, yeah. Hold a second. This is not right. Let me. So we do this. We try to find the first bit. Okay. So, but if come out, we say if I is equal to len strn. So there's no bits, right? So no bit is 1. So in this case, we simply return 0, right? That's it. The whole strn is 0. Everybody is 0. If everybody is 0, it's already 0. We don't have to do anything. Otherwise, we'll have the first bit. Then we try to count to here. Then if I is equal to len strn, right? So this is the case. There is only one set, only one. Okay. And we already know what that one is. So in this case, that one is going to be this, right? But hold a second. We can probably do it another way. Let's say, hold on. Let's say we do this if I is smaller than, okay? So what? So we say a second one is found, right? Because I plus equal 1, we have found a second one. So we have a first one, right? We accumulated k. We found a second one, right? It's equal to 1, so it gets out. So I is pointing to the second one. So what we need to do now is to do the dp for the, not dp, helper for the remainder, right? Helper for the remainder. So what we want to know, we have a k, so we need a p. Okay, we need a p. So p is equal to the total length minus this, right? P is equal to len strn minus I. Is that right? One zero zero zero. Len is 4 minus 1. I think it should be minus 1. Yeah, minus this plus 1 minus, yeah, we should do this. So that's the p. So there's a number of zeros at the end. So we got a p, right? Actually, at this point, we can probably get a result out. Okay. So for one thing, rest need a plus equal to helper strn. So we're gonna go from I plus 1 towards the end. So all of this, right, whatever it is, they need to become 0. So we do that, all becomes 0, right? Once they become 0, then we need to do this part, turn this part into this, which is this formula. Okay, so we can say rest plus equal to 2 to the p times 2 to the k, k plus 1 minus 2. Okay, so we add that, right? So that's we call it dp, but it's not dp, it's just recursion. So we have the recursion plus that, and then we need to plus 1, right? The rest to plus equal 1 again, because that is to turn from this into this. Wait, hold on. Let me recuperate everything that we've done so far. So we have a this, right? And we need to turn, now this from this into this, okay? And we do that. Now turn this thing into this thing, right? And then what we need to do is remove this, right? Remove this. Yeah, this part is turned into this. So we're plus 1 is to remove the first, first one, right? And then we need to plus the rest is going to be 2 to the total length, len is strn, right? Minus 1. So that's if I is smaller than, else no second one, then rest shall equal to rest of plus equal to, that is not right. This is not right. And we have to reconsider this. This is the starting from the first one, right, towards the end. How many? So we know the first bit. First bit. Right, we know the first bit. So it should be len strn, right, minus the first bit. Minus the first bit. That will be the total length, right? Minus the first bit is the total length of the whole thing, and then minus 1, right? And then we say if there's no second 1, then just be 2 to the so if no second, but we just have 1 bit, and everybody else is 0. So we basically just do this. Ugh. Yank it, paste it. Right. So this is what we will do. So if there's no second one, it's basically just the current one minus the first bit. Right, minus 1 is the total. This is the total line. Do we have to minus 1 though? I think in this case we don't do it. There's no minus 1. Right? Or minus the first bit. Yeah, total length minus the first bit is the length of the whole thing. And that's power, and then minus 1. Right? And then minus 1. And this whole thing, and then we'll return res. No, that's not right. Undo this. Return res. So if we do helper 0, we'll get, right, helper 0 will be fine, 1 0 will be fine, because the 0 comes in, everybody does 0, so it will be 0. 1 comes in, the first one is 1, and then I is equal to, that's not right. Oh, no, it's equal to 0, it's not equal to 0. So I is 0. First bit is 1. So I have a 1. Don't do any of this. Result is 0. I is not. So it'll be 2 times 2 to the power. Length is 1. First bit is 0. So 2 to the 1. 2 to the 1 is 2 minus 1. So it'll be 1. That's correct. So basically we'll return helper n. So we bin n 2 to the end. So 0 is 0. 0 is 0, right? Well, hold a second. Now we can actually go through that and just kind of check if everything is correct. Let's check this. Aha! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 100, 1000, 10,000. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. All right. Oh my God. What an effort. What an effort. But we got it. We got it. What a marvelous effort. I think we can make it better. Just a little bit. Just a little bit. For example, these are fine. This we will we don't have to say plus equal 1. We can just do res Right, so what we can do is we can say return, right? We can just directly return this plus. So instead of doing this, so 1 left shift P, right? So this will be 1 left shift P. This is 1 left shift. 1 left shift. This. You know what? Let's do a 3 parts. So it'll be temp1 will equal to delete this. Oh, this is the temp1. Right, it's a temp1. And temp2 is equal to this thing. In fact, I'll leave everything. Delete this. Go up and we'll paste this. And here we're just gonna go 1 left shift. So I delete this. We find this. This, right, and then we'll return temp1 plus temp2. Else, we simply return one left shift nope. Can we do this? Yes, we can. Okay, let's do this again. Nope. No. Go back. Do this. 52. Can we make it faster? 77. Oh, I guess the first round is. The left shift is taking a lot of time, huh? I thought it would be faster. It's the same. I don't like this version. I like this version better. So let's go back to this version. Actually, not really this version. I'm just gonna go this. Yeah, it's already optimized, so really you don't have to optimize yourself. And now we're gonna do to the end. To this, that's the temp1. Temp2 is this thing. Okay, so go down, find this, see to the end, this is temp2, and this is temp3, not temp3, the final result. This is no second one. Okay, we've done this. I'll submit one more time, but with everything written, but I'm not gonna keep recording because I think it's not necessary. So I probably will just cut it right now. All right, I will see you guys tomorrow. It's a good problem. See you guys tomorrow. Adios.